So this is a solo episode and I'm going to talk about a book I've been reading, and I've been making a few notes, and actually there's quite a few interesting things. So I guess for those of you who haven't been living under a rock, I guess you have heard of the recently published biography of Elon Musk by Walter Isaacson. And well, I'm not particularly an Elon Musk fan, but the book actually is quite interesting. And it's very well written, as one would expect from Isaacson. I remember I read his biography of Benjamin Franklin years ago, and it was pretty good. Very well documented and well put together and interesting. And it was a very fun kind of character. And it really made him come out as very human, right? And then, I don't know, when was that? Maybe 10 years ago, he came out with an authorized biography of Steve Jobs, right? And it came out just about at the time of Steve Jobs' death. And a lot of people were talking about it, and it was a big bestseller. And it was actually not a bad book, easy to read, interesting. Okay, even if you're not a fan of Steve Jobs, it's not a bad book. It's an interesting book. All right. And here is the same thing. So it's been authorized, right? So the author had access to a lot of family members and a lot of people who worked with Musk over the years and so on and so forth. So it's nicely documented. And I don't know, the publishers say that he could follow Musk for about 2 years, attending meetings, walking factories, interviewing him, and so on and so forth. So it is partly psychological analysis, and I'm not going to go into this. It does explain some of the weird behavior of Elon Musk. I think everybody heard of what he's done over the years. But it's also a nice and interesting business book. And I wanted to touch on perhaps what he does best is very good design for manufacturing, DFM, right? So design for manufacturing is something that must be done. Otherwise, you have sort of a nice conceptual design that looks nice, that you can prototype and it looks nice, but then it's very hard to make, very expensive to make, or maybe cannot even be made, right? And then you run into a lot of costs that are much higher than they should, and poor quality, and shipment delays and all kinds of things. And the manufacturer maybe even says, I'm not interested in making this, it's really too painful, right? So what's interesting is he's been working on SpaceX for more than 20 years now, and Tesla, I don't know, coming to 20 years soon, if they're not already there. And it's very interesting because SpaceX typically is a very high cost, where the products are not made are not designed for manufacturing. Really, it's very clear. NASA and Boeing and Lockheed Martin and all the typical contractors are good at making products sort of one by one or in very small series, in a cost plus type of contract, where the federal agency NASA basically tells them, here's the specs for making this rocket or whatever, this rover or whatever they have to make. And they say, okay, here's the cost, and you have to build in a bit of extra margin for us. And okay, we'll do the design, and we'll make prototypes, and we'll make production, but which is not really production in the sense of anywhere close to mass production, like in electronics or automotive and so on. Okay, and SpaceX from the start said, no, we're going away from that. We don't want to do cost plus, and NASA has to include us in the request for quotes and so on, and we'll just get paid whenever the rockets actually work, right? And they moved away from that, but really it's an industry where things are not really designed for manufacturing. It's more designed for working on one or two advanced prototypes, sort of, right? And then Tesla is sort of the opposite, where it's in the automotive industry, where you have companies like Toyota and Honda and others that have been pushing the boundaries, pushing the envelope really on designing more and more efficient production processes, right? And more like designing the cars, the products directly so that they can be made in a highly efficient manner. All right. So two very different industries, and Musk instinctively grasped some of that in a very in an amazing way, but in some other cases failed miserably and had to learn from his failures. Now, the good thing, you have to give it to that guy, he really recognized some of his mistakes and went 180 degrees. Okay, so I'm going to cover some of that in this episode. And yeah, one thing to get out of the way is that a lot of people are sort of fans of Elon Musk, and they say, well, this guy contributed so much, and obviously he he likes to give that impression. I don't think he really contributed that much, except for really shaking up his industries. Making humans a multi-planetary species, blah, 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 going to Mars. To me, that's sort of moronic. What's wrong with our planet, and why not try to make it better? But anyway, and Tesla, he basically claims he reinvented the electric vehicle, where to me, his contribution is that he kept the US in the race. Otherwise, I believe the Chinese manufacturers, with the strong support of Beijing and their strong interest in going to the next technology and not competing head on against the Japanese, the Germans, the Americans in internal combustion engine. Anyway, the Chinese probably would have gotten there. BYD and all the other brands that we see now. Obviously, they've been inspired by Tesla. They've learned certain things by dismantling some Tesla cars. It probably accelerated the shift, but Volkswagen probably accelerated the shift just as much or even more with their Dieselgate scandal around, when was that, 2018, I believe, when they were found guilty of hiding their emissions and not respecting the Clean Air Act or whatever it's called in California, and they got a big fine, and it was a big scandal, and the European Commission also said, well, let's move away from internal combustion engines and so on. So it's not just Tesla, right? So it's kind of hard to isolate really what his contributions have been. But yeah, what's pretty clear is that if he had not joined Tesla with pulled all his weight and invested so much money and pushed so hard, they would probably not have made it. The management team was really doing a terrible job. They did not even have a bill of material, and they did not even have an estimate of the total cost per vehicle made for the Roadster. So that was just, that tells you it was terrible. Anyway, good thing he went into it and really dispatched some people who knew what they were doing at some level anyway. So anyway, let's go into the meat of the book. As I mentioned, he learns through mistakes. And one of the mistakes, I remember he was very vocal about it. Maybe 5-6 years ago, he was saying, oh, we have to automate. This is going to be the most highly automated factory. And if the robot doesn't go fast enough, that you can't even see it moving, is not fast enough, we have to push it to go as fast as possible, blah, 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 blah. All of this was very theoretical. He was in love with an idea, he was pushing it, and all the people who actually knew something about high-tech automation of manufacturing processes were saying, no, this is not going to work. This guy doesn't know what he's saying. It's going to be very, very painful. And it's been very painful. They wasted a lot of money and time installing robots and seeing them really fail or how to say, slow their production down and make quality defects and so on and so forth. And at one point, some of the people working for him say, well, look, here, if we have 1 or 2 humans, it goes faster and it's more reliable. This is slowing down. This is a bottleneck. Let's just get this piece of equipment out and let's go back to more manual work. And from there, it became a mantra of his. And in the Nevada battery plant, they even opened a big door on the side in a wall just to get the automated equipment out into the parking lot quick, so they could switch from highly automated processes to more manual processes and just get going with production. Stop being slowed down all the time by excessively automated processes. So that's an interesting one. And another interesting point is that he really brought the product designers, the design engineers who work on the product itself. How to make it work the way it's supposed to work and so on and so forth, right? He made them responsible for the manufacturing process, something that came out a few times. There's some quotes about that, like, you're responsible for the production process. He did not make separate departments, or at least at SpaceX, he broke that and actually made them all part of the same team, more or less. And he co-located them with the manufacturing area as close as possible, so they could actually see the manufacturing process. And they had to walk the shop floor and really learn and see and observe and think of how to make the product better in a way that it's easier and cheaper to manufacture. Right? And this is something that he sees as his a strong competitive advantage, both at Tesla and SpaceX, in that they make a lot of the parts themselves, and they write all the software themselves, which is rather unique, I think, in the automotive industry. But making so many parts themselves is also quite unique in the aerospace industry, in my understanding. Right? So they can design the parts differently and move that into a new version in production and have these iterations, these improvement cycles relatively fast, much faster than the other manufacturers in their industries. And that's one of their competitive advantage, basically, to always keep improving, keeps making things faster, simpler, cheaper. All right. Over time, he formalized a lot of these learnings, again, learnings through mistakes. So one thing I would really chastise him for, I really I don't understand why he did not try to learn from the best manufacturers in the most advanced and most competitive industries. I mean, if he had tried to learn from companies like Toyota, Honda, and some others, he would have grasped a lot of that, but no, he had to learn it by himself. So anyway, after he learned it, he put it in a 5-point algorithm, and I'm going to read through these 5 points one by one. I think it's quite interesting. And the first one is question every requirement. Okay, so he doesn't like to just follow rules and say, oh, okay, you have to do that. Oh, okay, we have to do that. So let's just take it into account, right? Because then you have a proliferation of rules. So I understand that and I agree with it to a certain degree. If you keep adding rules and following all the rules, especially in highly regulated industries like that, then over time, you have rules on top of rules and so on. And a lot of these rules are outdated, or made sense maybe in the 60s or in the 80s, but over time it makes less and less sense. So he says question every requirement. Now, he goes a bit far with that, further than I would be comfortable with. There's some very clear regulations, and he just doesn't care. He likes to push against the regulations and sort of ask for forgiveness after, rather than asking for permission before, right? That's really the way he goes with that. But internally, inside his company, he always wants every requirement coming from the design, or not just every requirement, but every part of a product design needs to have the name of a product engineer, a product designer or product engineer, so that when someone says, so why do we have this here? Or why is this coated that way? Or why is it that shape? Or why do we even have that part? People cannot just say, well, it was specified like that. It's part of the design, so we just have to do it. Someone can actually drill down and go back to, oh, okay, it's that designer. Okay, I'm going to talk to him. I'm going to ask him why. And then Musk actually encourages people to push back and say, well, you think if this part is not there, for example, that problem might happen. Well, have you tested it? How do you know, right? Do you know for sure? And something that often he asks is, let's go back to first principles. Let's go back to the laws of physics. Is there a law of physics that actually prevents, that says that we must have that, otherwise it will not work? If not, okay, then we have to test. We have to think of it. We have to try to simplify, right? That's really something that comes back again and again. That's point 2 and point 3 in the algorithm. So I'm going to it in a second. Something he writes here, I'm still at point 1, question every requirement, is, okay, you need to know the name of the real person who made the requirement. Don't say it comes from the safety department or the legal department. You need to know who it is, and then you should question it, no matter how smart that person is. I'm quoting. Requirements from smart people are the most dangerous because people are less likely to question them. Always do so, even if the requirement came from me. Then make the requirements less dumb. So there's a lot of questioning the rules, because if you question the rules, that's how you get to the essential requirements, and that's how you make a product that will actually respond to these fundamental requirements in a better way. And I think that's a very smart way to approach this. But again, I'm not very comfortable in the way he does it. And he says, no, like, for example, no, let's just remove the radar from the Tesla. We don't need it. Like, people have been driving with their eyes, and vision sensors should be sufficient. Well, to which a lot of smart people respond, but wait a minute, this is an opportunity. We can have the radar right there. It's extra safety, right? If you remove it, you actually decrease safety. And it doesn't seem to make much sense just for reducing, removing that one part and making the whole vehicle a little bit cheaper. It doesn't make much sense. And it's like, no, let's just remove it. It will force us to become very good at using vision, like people's eyes, to allow the vehicle to go self-driving. And a lot of people think is nuts, right? But he doesn't care if, like, safety to him is nothing sacred. All right. Let's get to point number 2. He says, delete any part of process you can. You may have to add them back later. In fact, if you do not end up adding back at least 10% of them, then you didn't delete enough. All right. So that makes a lot of sense intellectually. Of course, if you remove some parts, that's excellent DFM, right? Excellent design for manufacturing. You keep things cheaper, simpler, of course. Fewer opportunities for quality issues and so on and so forth. You remove some processes. Of course, you make things easier, faster, cheaper. That's excellent DFM. But he wants people to be aggressive. He wants people to go too far and actually to the point where they see they have to add back. All right, so I hope there's quite a bit of testing. From what we know, at least in Tesla, it's not really the case. So that also makes me a little bit uncomfortable. It goes a little bit far in that direction. Is quite aggressive, and that in the end will lead to some catastrophic failures if you do that over years and years and years. And it probably already has, but he got away with it. Okay. Point number 3, simplify and optimize. This should come after step 2. Common mistake is to simplify and optimize a part or a process that should not exist. Yeah, that's for sure. First thing, and that's what, he's been rehashing things that a lot of people have known for a long time. Whenever you look at a business process, a manufacturing process, you map the steps, and first thing you say is, what can we remove? And then only after that you say, okay, how can we streamline it further? How can we, and how can we merge some of the steps? How can we improve some of the steps, and which ones need to be improved in priority? Maybe this one is a bottleneck. This one has very poor quality or speed, performance. Let's work on this in priority. This is nothing really unique here or new, I would say. But that's things he has learned over the years by himself. Okay. Number 4, accelerate cycle time. Every process can be speeded up, but only do this after you have followed the first 3 steps. Okay. Yeah, of course. Yeah. First work on the overall system, and then after that, go more on a point level kind of improvement, process step by process step, and see how you can speed them up. But first you need to look at the entire system. Again, nothing really special here. And then accelerate, faster, of course. Toyota's been working on that successfully for more than 50 years. Again, nothing very unique. And point 5, automate. That comes last. All right. The big mistake in Nevada and at Fremont, so that these two was a couple of Tesla manufacturing facilities, was that I began by trying to automate every step. We should have waited until all the requirements had been questioned, parts and processes deleted, and the bugs were shaken out. Yeah. You go into higher levels of automation, higher tech automation over time. There are phases, logical phases actually for that. Right. First, try to get the machines to provide the force to do the work, the transformation of the parts. Then maybe do automatic unloading, because automatic unloading is not very high tech. And then maybe after that you go into automatic loading, which is much higher tech, because you need the machine to be able to recognize maybe the parts and maybe to grab the part and position the part and so on. Much higher tech, right? So there's certain steps that you need to take into account. You can't just jump to high-tech automation like they did. It's total nonsense. Okay. Now, there's a few other points besides that algorithm that are worth mentioning. One thing I like is what he calls the idiot index. So he's a bit provocative. Maybe I would call it the waste index. But the way he looks at it, and he says, okay, let's take a full design of a product and let's compare the full cost of the bill of material to the cost just of the raw materials that go into this product, right? And in aerospace, you have sometimes a ratio of 1 to 100 or even more, because aerospace parts are very expensive because they are made to special requirements that maybe are not needed. So back to his algorithm point 1, question every requirement. And then he worked over and over to get the idiot index, as he says, to estimate the amount of waste, or at least maybe not waste, but to approximate the level of waste, right? And then from there, that helps him with step 2, step 3 of his algorithm. Okay, do we really need this part? In this part, do we actually really need this machining, for example? Do we need it to be made that way? What can we do to make it cheaper? And he would, when he sees a very high idiot index, he would give some stretch goals to his designers and say, no, try to make it 10 times cheaper. What would have to change? And that's a very good way of opening people's eyes, getting them to think, out of the box, as they say, in new ways. And in some cases, he really got very, very strong cost reductions. So I like that index. Maybe I would call it the waste approximation index or something like that. Okay. Another thing is he himself is relatively familiar with material science, having studied physics and actually started a PhD on material science. And one thing, for example, is that he pushed the designers at SpaceX to remove some of the carbon fiber parts that were relatively difficult to make and replace them by stainless steel. And people would say, but stainless steel is much heavier. Well, question that, right? Make the numbers, he would tell them. So do you need very thick stainless steel when the fuel, the liquid nitrogen and oxygen, are at very low temperature? Not necessarily, because lower temperatures make stainless steel stronger. Okay, so you don't need very, very thick stainless steel. And also, do you need a heat shield for the time when it re-enters the atmosphere and gets very, very hot? Maybe we can remove the heat shield because stainless steel has very high melting point, right? And also it can be welded easier, and it could be welded under a tent close to the site where the rockets are sent out. So that was very big insight, and he summoned his engineers to think about that and to run the numbers and to make prototypes and to test it. Right? So he likes to think about big changes and really question the wisdom, the commonly accepted wisdom in a certain industry, basically. Okay. Another story about stainless steel is when they designed the Cybertruck. So that sort of very modern, very edgy pickup truck, right? That is not in production, not that I know of, but that was unveiled a few years ago. It made a lot of noise. So his idea was, maybe let's use stainless steel and have the outside body of the car provide all the structural strength that the car needs. So we don't need all the usual chassis parts and everything that kind of hold it together. So let's design it in a completely different way, right? And because it's made of stainless steel, well, yeah, the outside is very, very strong and so on. It comes with a number of benefits, but also it has to be more angular, right? And then they say, let's come out with a design that's very angular. It's fine if it looks like something from the future, 50 years into the future, that's fine, that's good. He pushed for it. The designers came out with a concept. He said, okay, that's great, that's it, let's go with this. And a good part of the design studio hated it, but he just said, let's go for it. And when they unveiled it, they got some people to put down deposits, to be among the first ones to get it. That's sort of their market research, already far down the path of designing the product. But really, people would think, well, that's highly risky and everything. But if you appeal to 5%, you appeal very, very strongly to 5% to 10% of the pickup truck owners, plus some other people who do not have pickup trucks, but maybe are tempted by this new kind of truck. That's sufficient to get an entire automotive factory to run. Something they did not really explain in the book, but the author very often says, well, Musk has a very high acceptance of risk and so on and so forth. He does like snap decisions like this, and let's see how it comes out. In some cases, yeah, that's really what it looks like. But in some of the cases, I would dispute that. If you really understand how the automotive industry works, as long as you can have a factory that makes 300 or 400,000 vehicles a year to be fully utilized, you're making a lot of money, and you don't need half of the USA market to buy your product for that. You just need 5% of car buyers to really like your product, and you're making a ton of money already. So that does make sense to me anyway. And finally, I think that story came out last year that they are working with an Italian casting equipment manufacturer to make the largest piece of casting equipment in the world with 6,000 ton and planning to go even to 9,000 ton for the Cybertruck. And what's interesting here is the little story, again, a little bit of a DFM nugget, is he looked at a little toy version of a Tesla car, and he pulled it apart, and then he looked at the underbody of the car, which was all cast in one piece, which is quite common for small cars, right? Like toy cars, very small ones. That's very, very common. But then he brought it to the company and he said, well, why can't we do that? All the underbody is cast in one piece. That would that would reduce the number of parts enormously. That would remove a lot of the welding that has to take place. I mean, that would make the whole thing simpler. It would remove a lot of waste because it's cast, it comes out of the mold, you do a bit of machining, and that's it. It's ready to go. And well, he pushed them, and they contacted the major casting companies, and one of them said, okay, let's look into it, and they are making it happen, it seems. So this is again very representative of his approach of let's completely challenge the common wisdom about how people do things. Let's try to unlearn a lot of things and start from first principles and so on and so forth. So I found some of the examples in the book quite interesting and inspiring. So that's what I wanted to cover in this episode, and I hope that was interesting. It's not a short or small book that you can read in a short plane ride, but if you're into these kinds of stories, I think it's worth it. And there's an audiobook version on Audible that's pretty good. So well, I hope you enjoyed these few examples and the stories about Musk. All right, well, we'll be back next week as usual. Thanks a lot for following China Manufacturing Decoded.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.